Okay, so we are going to talk about something today called the chain rule. Now I want you to look at this first problem, okay, and it says y equal negative 3x plus 8 to the fifth power. And you might be wondering, oh boy, I've got to do a lot of algebra there to write this out to the fifth power. So that's like negative 3x plus 8 times negative 3x plus 8 times 5 times. Yeah, no, not going to happen. So what you can do is you apply what's called the chain rule. So now what happens is this is what we call here a composite function. A composite function, okay? A composite function. What does that mean? That means you have one function inside of another. Now, you've been dealing with this probably maybe since Algebra 1, where you have a function inside of another function. So what we're going to look at here is that negative 3x plus 8 lives inside of this function that's to the fifth power. Okay, so normally suppose we have x to the fifth power. Well, instead of writing x, we're going to write negative 3x plus 8 all to the fifth power. There is the composite function. It's composed of something. F is composed of g. And there's actually a really nice rule, and we call it the chain rule, that allows us to take the derivative of such a function. So if you have a function f composed of g of x, and you want to take the derivative, okay, and I'll write it out in the Leibniz notation, what you get is you take the derivative of the outside, f prime, you leave the inside, okay, and you multiply it by the derivative of the inside. And it's as simple as that. That is what this fancy notation here is telling you. It's actually the same thing, nothing fancy about it. But that's the way that it works, and we can now apply it to this problem here, number 1, and you're going to see how easy it actually is. It looks hard, but it's actually not. So if I take y prime, I'm going to take the derivative of the outside, which is something, and let's just call it u to the fifth power. So if I have u, let me write it in a different color. If I have u to the fifth power and I take the derivative f prime, I'm going to say 5u to the fourth. I apply the power rule. So here I'm going to have, in this case, negative 3x plus 8. That's going to stay the same, right? But then you have the 5 that you bring down. So it's a 5 right in front, and then this to the fourth power. Now I'm going to multiply it by the derivative of the inside. Well, the derivative of the inside is just linear, so the derivative of the inside is just negative 3. So times negative 3. So then I have my y prime, and I notice that I can multiply the 5 and the negative 3, and I'm going to get negative 15, and then multiply by negative 3x plus 8 all to the fourth power, and it's as simple as that. All right, there's nothing more to it for this chain rule. All right, so remember, again, you take the derivative of the outside and then you multiply by the derivative of the inside, and then you try to see if you can simplify. Okay, but let's go ahead and take a look at another example. Okay, so here's another example, and now this one we're going to be applying rules of trig functions, so trig derivatives, and that's always fun. All right, so let's go ahead and take a look at this one. Before we do that, we've got to think algebra first. Okay, so I'm going to have the cosine of x, and I'm going to have it to the fourth power. These two things are the same. So the reason why I do it is so that I can have a function inside and a function outside. When you look at it, the way that it's written, it doesn't quite look like that. So we rethink the way that it looks. But it's the same thing. They're equivalent statements. So now, to find the derivative y prime, I take the derivative of the outside, so it's like if it was u to the fourth, then the derivative f prime is 4u cubed, right? Where u is going to be the cosine. So I'm going to say 4 parenthesis to the third, and what goes inside? The cosine of x. Now I multiply it by the derivative of the inside, which is the derivative of cosine negative sign, all right? So this requires us to know the rules of trig functions or trig derivatives, all right? If I clean it up just a little bit more, I'm going to get something like this, which says y equal -4, okay? And then you're going to say, well, cosine to the third power of x times sine of x. It looks something like that, okay? Now, it is possible, maybe not on this example, but on other future examples, you can use trig identities to kind of simplify. So kind of keep that in mind, that those trig identities are so important, and they really go a long way. All right, I think we have time to do one more example, and we should do that example, and it's actually a really nice one. So let's take a look at it. Okay, last example, promise. So we have this function that we're asked to find the derivative, and if you notice, it says q equals the square root of 12r minus r to the 7th. We have to rethink the way that it looks. We have to think algebra first. We have 12r minus r to the 7th, all to the 1/2 power. Okay, all to the 1/2 power. So we have to pretend that we've got this like u to the 1/2, and what does that look like if I take the derivative? Okay, it's 1/2 of u to the 1/2 minus 1, which is -1/2. Okay, so what we're going to look at, what we're going to look like here, is we're going to have this with a 1/2 in the front, a -1/2 on the outside, and on the inside, it's going to stay 12r minus r to the 7th. Okay, that's fine for right now. Now we're going to multiply by the derivative of the inside, so I'm going to put parenthesis. The derivative of 12r is just 12, and then minus, and then the derivative of r to the 7th is just a power rule derivative, 7r to the 6th power. Okay, so it looks something like that. It's not really terribly bad, all right? And this right here is the basic setup of q prime, but you can simplify q prime, okay? Because I see that I have a negative exponent, which I can put in the bottom, which is a square root. I can multiply by that by 2. So the bottom is what we can clean up first. We have a 2, then we're going to have a square root of 12r minus r to the 7th. It looks something like that. And then this right here stays in the numerator because it gets multiplied by that 1 that's up on top of the fraction. So 12 minus 7r to the 6th. Okay? And that is what this derivative looks like using the chain rule. So again, just to recap on the chain rule, all right? There's the chain rule. You have a composite function, f of g of x. Okay, 1 second, let me fix that. F of g of x, and you want to take the derivative. Okay, what does it look like? It is f prime of g of x times g prime of x, the derivative of the inside, derivative of the outside, multiplied by the derivative of the inside. And it is possible to have more than one inside. So there could be more inner parts, like a layers of an onion, if you will. All right, you may have to do the chain again. And in that case, you know, I see something like that, you know, a chain within a chain. And I always say, I have 2 chains. All right, that was just a joke. But anyway, I hope this video was helpful. And if it was, remember, like and subscribe.